Hey you guys, so you've been talking about forces in fluids like pressure and such. So today there's one more force you need to learn about, which is called the buoyant force. Buoyant. So this relates to something I bet you've done in real life. Say this rubber ducky represents a beach ball. Okay, it floats. Now when you try to push it underwater, usually you feel a lot of pressure, and when you let go, it bounces back up. So we're gonna check out what was that force that was pushing up. So let's compare three things we're used to. Ping pong ball first. Okay, so ping pong ball definitely floating. We've got bouncy ball. Okay, bouncy ball is floating still, but it's sunk kind of low into the water. We're gonna talk later about the difference between those. Third one, golf ball, which obviously sinks. Now, if things are floating or sinking, we have to look at the invisible forces on them. So what force is pulling down on all of the balls equally? Gravity force. So there's another force pushing upward. So for the bouncy ball and the ping pong ball, they are not really going anywhere up or down. So that means the forces are balanced. For the golf ball, the gravity force pulling down, which means weight, is winning, and therefore it's sunk. Luckily, there's a way that we can measure the forces in newtons. So there's a cool way we can measure that upward force, the buoyant force, by using displacement and the spring scale like you used in your friction lab. So let's drop the ping pong ball in, and the water that's displaced or pushed out of the way will overflow into the little beaker. Here we go. Okay, a little bit of water's going in. Now, I already adjusted the spring scale to account for the weight of the container. Okay. So, spring scale shows that the water displaced by the ping pong ball weighs 0.1 newtons. Next up is the bouncy ball. Okay. So you can see it's sitting lower in the water, so you can tell it's displacing more water. The weight of the displaced water is 0.3 newtons. So the buoyant force pushing up is 0.3 newtons. Okay, our last situation is the golf ball. So let's drop it in. Now you see it sank all the way to the bottom, so it's displacing the whole sphere shape of water. Okay, and the weight of displaced water from the golf ball is 0.5 newtons. Now, earlier we said the ping pong ball and the bouncy ball were balanced forces, and the weight down and the buoyant force up must have been canceling each other out because the balls were just sitting there. Now, the golf ball has sunk to the bottom, so the weight pushing down must be greater than the buoyant force pushing up. Now, this one's a little tricky because you might think, well, it's not moving, so those must be balanced forces too. But really, what's keeping the golf ball from going lower? It's the bottom of the container and this tray. So if we had some kind of a beaker that was 10 feet high and we dropped a golf ball in, would it only sink down a little? No, it would sink all the way down to the bottom. So in this case, unbalanced force with the weight being greater than the buoyant force pushing up. Okay, so in your float the boat challenge, your task was to make a boat out of foil that could hold the most weight. So let's think of that in terms of buoyant force. So if it holds a lot of weight, weight is pushing down, buoyant force is pushing up. To have a great buoyant force, you need to push away a lot of water. The weight of displaced water equals the buoyant force. Now, the most two common hypotheses I heard from you of how to hold the most weight was either a big surface area on the boat or a boat that goes in deeply because it has tall sides. So people were telling us how many weights or pennies or Sour Patch Kids or beans your boat could hold before it sank. So both of those shapes can work pretty well. Let's do a little comparison looking at the boat with a small surface area but high sides. This will help us understand the difference between the ping pong ball and the bouncy ball. So right now, this is like the ping pong ball. So does it look like the amount of water being displaced by the boat is a lot or little? To me, it looks like a very little amount of water. Since the weight of displaced water equals the buoyant force pushing up, that's really low. And the weight that's pushing down is the same because it's balanced. So that means the weight of the ping pong ball is really low. That totally makes sense. So what do you think happens for the bouncy ball? Since the weight pushing down is more, what do we know about the buoyant force pushing up? That also has to be more. So representing more weight, I will carefully put weights into the little boat. So as I add more weight, you can see the boat is sinking lower in the water, which means it's displacing more water. So an object sinks until the water it displaces equals the weight of the object. So I'll say that one more time. An object sinks in the water until the weight of displaced water equals the object's weight. In this case, you can see it sank. So that means the weight won, which is what happened with the golf ball, and the amount of water it pushed away, even though it's the whole volume of the object, it is not enough to equal the weight that pushes down, and so it sinks.